Hi to you watching this video. So we are still on module number 4, but we are already on the last unit, unit number 6. So time rate of consolidation. So we have here our assumptions. So number 1, the clay water system is homogeneous. Number 2, saturation is complete. Number 4, compressibility of water is negligible. Number 5, compressibility of soil grains is negligible, but soil grains rearrange. Number 5, the flow of water is in one direction only, that is, in the direction of compression. And number 6, Darcy's law is valid. Okay, now for time factor, TV is equivalent to the coefficient of consolidation, CV, times time, divided by the average drainage path during consolidation. Now for HDR, it is HDR if it is passing through or exiting at one point only. But if it is exiting at 2 points, or top and bottom, we are going to have it or to divide it by 2. Okay, so don't worry, we will be having an example of this. Now, for the degree of consolidation, which is U, at a distance Z, at any time, UZ is equivalent to 1 minus small z over small z divided by small u sub o. Okay, and average degree of consolidation at any time u is equivalent to the settlement of the layer at time t divided by the ultimate settlement of the layer from primary consolidation times 100. So you have here the legends. Okay, now, approximately for you, if it is 0 to 60%, therefore, time factor or TV is equivalent to pi over 4 times u divided by 100 quantity squared. But if your u is greater than 60%, therefore, time factor or TV is equivalent to 1.781 minus 0.933 logarithm of 100 minus u. So be careful with our u here. Okay. The variations TV are also shown in table 4.6, but if the value of u cannot be found in table 4.6, then it is better to use equation 4.47 and 4.48 to avoid possible errors due to interpolation process. So this is table 4.6. So if we have our u, then we can now have our TV here. Okay. Now, methods in determining CV or the coefficient of consolidation. So we have the logarithm of time method, we have the square root of time method, and lastly, we have the hyperbola method. Now, calculation of consolidation settlement under a foundation. If we are going to calculate consolidation of settlement under a foundation, we have here an assumption. The pressure increase parabolically. Okay, and according to Simpson's rule to estimate the delta sigma prime average or the average increase in effective pressure is given by delta sigma average prime is equivalent to the increase in effective pressure at the top plus 4 times the effective pressure change in the middle plus the change in the effective pressure at the bottom divided by 6, okay, to get the change or the increase in the effective pressure average. Okay, yeah. Now, we have here the differential settlement. Now, structural problem when two or more footings exhibit different settlement as shown in the figure. So, for example, we have here, imagine itong footing natin, nandito pa siya sa B. Okay? Now, nagkaroon tayo ng settlement and for example, this is your footing 1, this is your footing 2. So, magkaiba yung level ng settlement ni footing 1 and ni footing 2. Now, we need to check if the settlement is below 0.002 radians. So, the change in the settlement divided by the length or the um, on-center distance of this two footing. Okay, so the change in settlement, I repeat, so the change in settlement between footing 1 and footing 2 divided by the on-center distance is less than 0.002, then it is okay. But but if theta is greater than 0.002, then we need to provide tie beams because columns and beams, no, the columns and beams or of your superstructure are already overstressed and having greater moments, and thus it will be creating an impact to our structure. So, dyan na tayo magkakaroon ng cracks kasi overstressed na siya. So, magkakaroon tayo ng mga cracks or yeah, magkakaroon tayo ng cracks kasi uh, hindi na uh, what do we call this? Hindi na pasok sa limit yung difference nila in its elevation. Okay? So we have here a sample problem. So referring to the figure, a 2 by 2 footing, so 2 by 2 footing in size supports a column load of 300 kilonewton. So we have here a 300 kilonewton load, and the soil characteristics are given in the following figure. So field monitoring indicated that the foundation settlement was 19 mm during the first 12 months. So letter A, estimate the average stress increase in the clay layer due to the applied load. So what is the average stress dito sa ating clay? Okay? Letter B, estimate the primary consolidation settlement. And letter C, we have what is the degree of consolidation after 12 months. And letter D, estimate the coefficient of consolidation for the pressure range. So we have here the unit weight of the dry, the unit weight of the saturated, and we have here the characteristics of or parameters of the soil. So here we need to solve for the unit weight of our clay. So what are the given? We have P with we have B time is equivalent to L, which is 2 by 2. Okay, we have the unit weight or gamma dry, gamma sat, and we have here the characteristics of the clay. So first is we need to solve for the unit weight of the clay, and it is gamma sat. But we cannot yet directly solve for our gamma sat here because we do not have the void ratio. What we are given is the moisture content, the specific gravity, liquid limit, the pre-consolidation pressure, and we have the CS, okay, which is equivalent to 1 over 5 of CC. So we know that SEWGS, if you can remember that formula, we have SE is equivalent to WGS. But take note, it is below water, the table, it is below water table. Therefore, saturation is equivalent to 1. E therefore is equivalent to the specific gravity times the moisture content. So E therefore is equivalent to, we have 0.6576 EO. And that is equivalent to the initial void ratio. Then from there, we can now solve our gamma sat. And that is given by specific gravity times the unit weight of water plus the times the um, void ratio times the saturation, which is 1 times the unit weight of water divided by 1 plus E. Therefore, gamma sat here is equivalent to 20.108 kilonewton per cubic meter. Okay? So, ang pinapahanap sa atin sa letter A is the average, weighted average of our, what do we call that? Estimate the average stress increase in the clay layer. So since it is average and according to Simpson's rule, it is the top, the middle, and the bottom. So we need to determine the stress at the top, the middle, and the bottom. Now, if you can recall from our previous chapter, wherein we determine the the uh, increase in vertical stress below a rectangular footing, and it is at the middle, then gagamitin natin yon. Kung maalala niyo yung equation na Q times I4. Okay? Yun yung gagamitin natin. And with that, we need first to solve for our Q. And we are given our force to be 300 kilonewton. And for the area, take note that the footing is square footing. So we have here 2 by 2. So 300 divided by the area of 2 by 2, this is equivalent to 75 kilopascals. Okay, now it would be easier if we will be use tabulation. So for tabulation, we need to specify what points are we trying uh, to to analyze here. So take note sa specimen natin or sa ating given, we need to determine the top, the middle, the bottom. So it will be TMB. Next, for our criteria, for our parameters, it would be M1, Z, N1. M1 and N1, tapos Z. Then from there, pwede na tayong makaproceed from our table 2. Take note, if you can remember, M1 is equivalent to L over B. But for this one, all of which are 1 sa top, sa middle, sa bottom because L is equivalent to 2 and B is equivalent to 2. True for all. So this is equivalent to 1, 1, 1. Next, for the Z, it is measured from the base of the footing downwards. Okay? So this is our Z1, which is 1. Z2 is 2. Z3 is 3. Okay? From the base of the footing. So we have 1, 2, 3. Okay? Next, we can now solve for our N1. So N1 is equivalent to 2 times Z divided by B. B is just the same, which is equivalent to 2. So 2 divided by 2 is 1. 2 divided by 2 is 1. 2 divided by 2 is 1. Z is 1, 2, 3. So it is again the same 1, 2, 3. Wait. So we have here 1. We have here 2. Then we have here 3. Now from the table, go back to table 3.10. Then you have there your M1 for the horizontal, then N1 for the vertical. Then makukuha na natin yung value ng I4 natin. So for the T, it is 0.701. Then for M, it is 0.336. Then for I3, it is 0.179. Okay. Now to determine now our delta sigma z, we simply multiply q by its I4. So ang q natin is 75 times 7.01. This is equivalent to 52.575. Next, we have 75 kilopascals times 0.336. This is equivalent to 25.2 kilopascals. And lastly, we have 75 kilopascals times 0.179. This is equivalent to 13.425 kilopascals. Now, to get the average, we use the Simpson's formula. So we have the top plus 4 of the middle plus the bottom divided by 6. Okay, so 52.575 plus 4 times the middle plus the bottom divided by 6. Therefore, delta sigma average prime is equivalent to 28 kilopascals. Okay, so pwede na nating palitan yung ating yung ating footing dito sa taas ng uniformly distributed load, which is equivalent to 28 pascals. Okay? Yan. So, papalitan natin itong footing. Gagawin na natin siyang 28 kilopascals uniformly distributed load dito. Okay? Okay. So, next is we can now solve for letter B, primary consolidation or SC. But before we can do that, we need to solve for the value of CC. Okay. Now for the CC, we are given we can solve that using the empirical expression of Skempton of 0.009 LL minus 10. Okay, so liquid limit natin is 46 minus 10 times 0.009. This is equivalent to 0.324. Okay, then the thickness or the height of the clay layer is equivalent to 2 meters here. And then the initial or the original in situ void ratio is 0.6576. Then the overburden pressure. Now for the overburden pressure, it is the unit weight of the soils. Okay, and it is the effective. So it is the summation of the effective unit weight times the z. So we have here 14 for the dry times 1 meter plus we have 17 for the saturated clay minus 9.81 because we need the effective times a thickness of 1 meter plus we have here the unit weight of the saturated clay, which is 20.108 minus the unit weight of water times 2 divided by 2 because it should be at the center. Therefore, delta sigma sigma sub 0 prime, or it is equivalent to overburden pressure is equivalent to 31.488 kilo Pascal. Now we need to check whether uh, the the pre-consolidation pressure is greater than or less than our overburden pressure. Okay? So we need to check that. So ilan ba yung ating pre-consolidation pressure? Our pre-consolidation pressure is given as 40 kilopascals. So it is given as 40 kilopascals while our over pre-consolidation pressure and our overburden pressure is equivalent to 31.488 kilopascals. Okay? Therefore, from here, mas malaki yung pre-consolidated pressure natin compared sa overburden pressure. Ibig sabihin, it is over-consolidated clay. Now, we check, no? Since it is over-consolidated clay, we use for a primary consolidation, it falls under over-consolidated clay. Okay, then from there, i-check natin if we're going to use the shorter equation or the longer equation. So, i-check natin yung overburden pressure natin plus our uniformly distributed load if it is greater or equal to our pre-consolidation pressure. So, overburden pressure 31.488 plus our uniformly distributed load which is 28 kilopascals, yung na-solve natin, yung pinalit natin dito, is equivalent to, anong value nito? This is equivalent to 59. 59.488 kilopascals is greater than 40 kilopascals. Therefore, we are going to use the longer equation. And this will be our working equation for the preliminary consolidation. Okay. Now we do not have the C sub S. We have the H, or we know the H. We know E sub O. We have delta C prime, delta 0 prime. Therefore, ang isosolve na lang natin is the swell index, and it is 1 over 5 of the compression index. And our compression index is 0.324. So 0.1 over 5 of 0.324 is equivalent to 0.0648. Okay. Now substituting into our equation, SC, therefore, or the preliminary consolidation, is equivalent to 0.0755 mm, meters. And that is equivalent to 75.5 millimeters. That is for the preliminary consolidation. Next, solving for the degree of consolidation, it is after 12 months. So we use equation 4.46 where degree of consolidation U is equivalent to the settlement of the layer at time t divided by the ultimate settlement of the layer from primary consolidation. Okay, so times 100%. Now, what is the degree? What is the settlement after 12 months? It is given as 19 mm. Okay, and the ultimate settlement of the layer from the primary consolidation was solved to be 75.5 millimeters. Okay, so we have here 75.5 mm times 100%. Therefore, the degree of consolidation is equivalent to 25.165.6%. Okay. Letter D, the coefficient of consolidation, CV. So approximately for the U, what is the value of U? It is 25%. So again, meron na naman tayong dalawang equation. Sabi kanina, it's either equation 1 or equation 2. Balikan lang natin. Saglit. Okay. So we have here, ito. So, wait. Ito. So for U, 0 to 60%, this will be our TV. But for greater than 60%, this will be our TV. But our U is equivalent to the range is equivalent to 25, which is between 0 to 60. So this will be our TV. Okay, so TV is equivalent to pi over 4 times U divided by 100% quantity squared. Okay, okay, going back. Ayun. So we have pi over 4 times u, which is 25.1656 over 100 quantity squared. Therefore, this is equivalent to 0.0497. Okay. Then from equation 4.44, we can now have TV is equivalent to C sub V times T over HDR squared. So here we are going to solve for our, we can now solve for our consolidation coefficient or for the coefficient of consolidation using equation 3.4 because may TV na tayo, we know HDR, we have the time. Okay? So we can now solve for TV. So cross multiplying HDR to the other side of the equation and T to the denominator, CV therefore is equivalent to TV times HDR squared over time. So the value of TV is equivalent to 0.0497 ni 0.0497 times what is the HDR. So yung height ng clean natin is 2. Okay? But this time we are going to divide it by 2. Why? Because from our from our um, from our given dito, hindi naman pores hindi naman impermeable yung dito sa ilalim. So yung yung exit natin, it will be on the top and at the bottom. Okay? Kasi hindi naman siya impermeable dito. If this is impermeable, then HDR lang siya. But since this is not impermeable at here, so pwedeng mag-exit yung water dito and exit din dito, then HDR over 2. So that would be 2 divided by 2 and divided by 12 months. So T will be dependent kung months ba siya, kung years ba siya, kung weeks ba siya. Okay? So it would be 12 months. And therefore, CV is equivalent to 0.00414 square meter per month. And that would be our coefficient of consolidation.